Good day, everyone. We'll be presenting on the quarantine violation detector. Members of the group are myself, Najee Porter, Rajiv Smith, and Sanjay Daly. Our supervisor is Miss Carly. Moving on to the introduction, the quarantine violation detector is identical to a wristwatch that can also be fitted to the ankle. To have an idea of what we're talking about, you can relate this to a house arrest device. Our design uses the Arduino Nano board to collaborate with the MLX9614 infrared for temperature sensing. It also uses the STIM5320E module for GPS tracking and the polyurethane rubber band with lock screws for added tamper-proof protection. Lock screws are like some rare type of screws, really, so yeah. Now, there are some objectives that we put in place for the quarantine violation detector. First one, provide the administrator of the device a live log for the location of the user at specific time intervals. Allow functionality of the device to read and display the temperature of the user. Alert the administrator when the device is removed from the ankle or wrist. Allow for the design to not negatively impact the mobility of the user. Ensure the device does not emit noticeable heat that will cause discomfort to the user, and also allow for the device to be waterproof up to a specific depth for a period of time.
How did we reach to the point that we decided that these were objectives that my partner and my group partner had just mentioned? I am Rajiv Smith, and I'll be doing a brief overview of our review. The world as we know it today is definitely not the world that we knew 2 years ago, as we all know. As of December 2019, we had reported our first case of the coronavirus in Wuhan, China, and since then, tons of lives were lost. Economies had been suffering drastically. And of course, we have stumbled across many articles expressing themselves on how the virus had impacted their economy, their livelihood, their way of living. And the list could go on and on and on. In reference to one of the many articles that we have stumbled across, Rashid Kaphan mentioned on April 11, 2020, and the slide reads thus: the number of people with a travel history and on their home quarantine had surged. Lockdowns, geographical area containment are becoming the new norm. Tracking such citizens manually had become nearly impossible, he expressed, and went on by saying violating quarantine could be devastating for the community desperately trying to evade the dreaded COVID-19 virus. If you do have our report nearby, you'd see with many other reference of many articles stating how they had found their solution. One went on by using an app which Jamaica also use, where you periodically take photos and upload it, and of course there's a GPS tracker on the app that is installed on the phone. One that practically stood out was the method that Greece used. They use drones as mass surveillance to ensure persons do not violate quarantine, or whatever the case might be. In this case is quarantine. I do apologize for that. But Greece went about their thought of bringing drones to do surveillance around the several areas where the identity of persons would be scanned, and biometrics, all those works that come with identifying someone. And they had a problem with the law because this this method is indeed impeding on persons' personal lives and personal space. So that method, for one, would not be so practical in a sense. So that one kind of stood out, but it was actually innovative to us. But moving on. This is just much of a graphical presentation expressing how the numbers of the coronavirus had been spiking thereabout, and as you can see, we are very much approaching 1 million, even though we are at a period low. As you can see, it is stated in the news in recent times that, which the date is December 18, 2020, that there should be a third wave coming our way. So unfortunately for us, we are far-fetched from overcoming this virus, but with the heads of our UTech engineers, we trust that our method will be out there. I know for sure you have this one question in mind right now, given all these methods that we expressed in our little review that we have expressed earlier in our presentation, is what would make our quarantine violation detector much different from the rest. But we'll get to that. But as of now, as seen on the slide, is very much of a basic flowchart of our detector. So starting off our flowchart, we have our device being worn by the user. The immediate diverse from our chart is the tamper-proof band, and of course, tamper-proof band will be incorporated to send information to our administrator if tampered with. We'll get a little more into that further down into this presentation. Going back down to our next process in our flowchart, which involves our microprocessor, which has two main components: the temperature sensor and the GPS tracker. Of course, these components are detrimental to our design because this is what we really need and this is what we really want to monitor and to ensure that persons are not violating quarantine protocols. But of course, our temperature sensor sends information to our administrator, sends information to our administrator, sorry about that, and our GPS tracker also sends information to our administrator. We get into a little more detail in each specific component of our design, but as of now, we'll be just moving on. As you can see, this is just a flowchart of our GPS tracker design. Yes, we have a GPS tracker. Yes, we have a specific module that we'll use. Yes, we'll implement it on our microprocessor board. And yes, from the microprocessor board, we'll send the information to our administrator. As you know, as you might imply rather, that this would be one of the major, if not the major component of our design, whereas it tracks, sends information to the administrator as fast as we want it to. I honestly hope that we haven't lost you guys as yet. Just be with us. We are getting to the nice where we're actually putting our system together. So yes, in implementing our GPS tracker, we connect our GCM and GPS antenna to the module, after which we connect our 5V and VMCU pin to the positive terminal of the battery and to the ground pin of the negative terminal of the microcontroller, of course. After pulling up the board, we take note that the LED light was starting to blink, which indicates the board is now excited with current. And in connecting our GPS tracker module to our microcontroller board, which is by the name of the Arduino Nano board, we connected the XD pin to pin 10 of the board and our SRXD pin of our GPS module to pin 11 of our microcontroller, and it grounded, and we did ground the GPS tracker to the ground potential of our microcontroller. We then went on by uploading our code to the board, or again we should upload the code to the board and send command to our GPS module.
Now JPort here again, and I'll be taking a look at the core commands for the GPS module. Basically what we're showing here is just some of the commands that will be frequently used. So to initialize the process, we input 2 sets of commands. Then after that, what these commands do, it basically grabs the location of the user, provided that the user has a SIM card with data activated in the module. So the first number would represent a latitude, and the second number would represent a longitude. What you can do with these numbers, you can just go onto Google Earth, paste those numbers, and those numbers will reveal the exact location of where the device is. Also, the administrator has the option to set a custom phone number for where the information can be sent to.
Hello everyone, my name is Sanjay Daly, and today I'll begin my part of the presentation by explaining the operation of the design aspect of the temperature sensor. Here on the screen we have a flowchart of how the temperature sensor works. At the beginning of the flowchart we have the infrared thermometer. Now this infrared thermometer works by employing a lens to focus the infrared light emitting from the object onto the detector, known as a thermopile. When the infrared radiation falls on the thermopile, it gets absorbed and converts it into heat. Following this, the proximity sensor then detects the changes in the field and returns a signal to the Arduino Nano board. This board then sends or relays the information to the administrator. The board will at the same time compare the data of a normal body temperature to that of the data which is collected if the body temperature of the user is higher than that of the normal body temperature. It will then send a signal to the piezo buzzer, which will then indicate to the user that his or her body temperature is above normal. Now we'll move on to the implementation of the temperature sensor. In the flowchart shown before, it showed the infrared thermometer and the proximity sensor being connected in series. However, in reality, the temperature sensor and the proximity sensor along with the LED display are actually connected in parallel. This is due to the fact that they are all I2C sensors. And this means that they all need to be connected to the SCL and the SDA pin of the microcontroller. SCL refers to serial clock and SDA refers to the serial data of the microcontroller. Now, the serial clock line is a clock signal which synchronizes the data transfer between the device and the I2C bus, while the SDA line is the one which carries the data. Following this, we move on to the piezo buzzer. And as was stated before, the piezo buzzer is used as a warning device, as a warning mechanism to warn the user that his or her temperature is above normal, is very high. And the piezo buzzer is really a device a battery charging device that is soldered onto the designated pins of the microcontroller.
Well, taking a look at the tamper-proof band, this band will feature whereas the band is reinforced to the metal casing holding the circuit using the lock screws. There will be 2 holes row by row for the entire band. There will then be a metal casing on both sides of the band that will be screwed together with the polyurethane rubber in the middle, aligning with the holes. So taking a look at the right, you will see like an actual picture of a lock screw, and you will also see like an example of how the band will look really, just a layout.
Now, in implementing the waterproof part of the technology, we decided to use a product called Loctite. It is a multi-purpose adhesive and sealant which creates a protective and waterproof seal that works with materials such as metal, rubber, glass, or even porcelain, among other materials. It is used by cell phone makers to make cell phones and other gadgets waterproof. Hence, it is very ideal for making this gadget waterproof.
Going through this presentation, you may be asking yourself, what is so unique about our project light? What makes it different from the current technology that's been used by various countries such as China and Germany? Well, the key component in our uniqueness is the piezo buzzer. This device will alert the user that their temperature is above a specified value. The user will know immediately to seek medical help.
On this slide, we see the task breakdown menu. It includes the duration and the start date of each individual task. Now each task is numbered by means of T1, T2, T3, and it goes up to T21. Under the title, you'll see the name of each task, namely the development of problem statement, analyze current existing systems, compilation of proposal documents, among other titles. On the far right of the schedule, you'll see the start dates of each task. The project started on the 14th of September 2020 and is scheduled to end on the 17th of May 2021. Under the duration title, you'll see numbers outlined in a column form. Now these numbers, even though they are of different shades, are indicators of how many days it takes for each task to be completed.
I really hope you had found what my group members expounded about our design very, very informative. And yes, it's Rajiv again in explaining the chart, the Gantt chart on the screen or on the slide right now. Is that this was the scheduled time, and this is just a graphical representation of what my fellow group member Sanjay Daly was explaining or told you guys about the different tasks that we had set out and the different time schedule that we had planned. So this is just a graphical representation with the corresponding task that is associated with the duration of the task at hand, that was at hand, because this semester had passed. So on to the next graphical representation of the semester 2 or the intended graphical again, this is another graphical representation of our intended plan of sequence of events that we have to do in the upcoming semester 2, to complete the task at hand, which is to design our quarantine detector.